Example 9.3.3 hypothesis test for two means. Okay, and uh, I very like this example because it's very practical and about daily life situation. The amount of sodium in beef hot dogs was measured. In addition, the amount of sodium in poultry hot dogs was also measured. The data in example 9.3.2 is enough. Is there enough evidence to show the beef has less sodium on once a week or twice a week? Okay. And here, let's check the information. Table 9.3.2, hot dog data. Sodium in beef hot dogs, like this one. And sodium in poultry hot dogs, look like this one. Okay, and now, first, state the random variables and parameters in words. Okay, the solution, X1 is the sodium level in beef hot dogs. X2, the sodium level in poultry hot dogs. And mu1, that is sodium level in beef hot dogs. Mu2, the mean sodium level in poultry hot dogs. Okay. The normal hypothesis would be non-hypothesis, they are equal. The alternative hypothesis, they are not equal, and the alpha level is about 0.05. A random sample of 20 sodium levels in beef hot dog is taken. A random sample of 20 sodium levels in poultry hot dogs was taken, but the problem did not state if the samples were randomly selected. So this assumption may not be valid. Okay. Maybe those beef hot dog was selected from Pennsylvania, or maybe the chicken hot dog was selected from Ohio, maybe. So it's not a random selected, two samples are independent since these are different type of hot dogs. Okay, they are independent. Population of all sodium levels in beef hot dogs is normally distributed. Population of all high sodium levels in poultry hot dog is normally distributed. Okay, all of them are there. Okay. From the distribution, sodium level in beef hot dog look like this, a little bit close to the bell shape, but not complete. And here is the box plot of the beef. And here is the poultry hot dog, the sodium content. Wow, it's not a bell shape. Instead, it looks like a completely different. Look like this. Very weird. You see? And now, this does not look linear, so the population of all sodium level is probably not normal distributed. This assumption is not valid, since the samples are fairly large and the t-test is robust. It may not be a large issue. However, just realize that the conclusions of the test may not be valid. Okay, and the population variance are equal. Okay, this one. Okay, S1, this one, S2, like this one. Okay, and so you can say the variance are equal. Okay. And number 4, find the test statistic and p-value. Sample statistic, the X1 bar. X1 bar is the average sodium level in beef huddle. That is 401. And X2 bar, that is the sodium level in poultry huddle. That is 450.2. And standard deviation of the first one, 102. For the second one, 81. The total number taken from the sample one, from the group one, that's 20. Okay. And try to calculate this. And the assumption sigma square, they are equal. So the pooled standard deviation look like this. 92.18. And the t-score look like this one. And it's minus 1.678. 1.678. And the degree of freedom, 20 plus 20 minus 20, that is 38. And we got the this one. Okay, the pooled question on the calculator is for whether you are using the pooled standard deviation or not. In this example, the pooled standard deviation look like this one. S with a footnote P. Was used since you are assuming the variance are equal. That is why the answer to the question is yes. Then use R and this one, and in the end, get the p-value is 0.5096. So alternate hypothesis, true difference mean is less than 0, and 95% of the interval look like this. Thus, even they set alpha level to 0.05, but the p-value is a little bit larger than 0.05. But according to the rules, fail to reject non-hypothesis. Since the p-value is a little bit larger than the alpha level. Okay, and the conclusion is there is no enough evidence to show the beef huddle has less sodium than poultry huddle. Though to realize that many of assumptions are not valid, so the interpretation may be invalid. Okay, and now let me show you how to run this one. And we can ignore this one. Okay. First, okay, let me change the size of the screen. Okay, and create a new sheet. Okay, then you can follow my steps. And select the range. and copy and paste it here. Paste it here. Okay, and this time, I encourage everyone to use the website directly. For example, this one, last year I used this one. And now t-test calculator. Unpaired t-test. And last week we shared some information about the t-test here. Then we select unpaired t-test. The group 1. Copy. Group 2. Oh, sorry. I select this one. Enter or paste up to 2,000 rows. Poultry. Beef. Okay, and calculate. Okay, and let's check the information here. Okay, and after calculation, we can compare the right and left side. First, standard deviation from the beef is 102 here. Standard deviation of the poultry 81.1, 81.18, the same. And the number 20, okay. And the degree of freedom 38. And poor the standard deviation didn't show on here. Show here. Yeah, degree of freedom 38 is very simple. And the two-tailed p-value is 0.1, 0.1, and here the p-value is 0.05, half of that, because it's two tails, we can switch it, and the r squared, the p-value is 0.1, thus by conventional criteria, the difference is considered to be not statistically significant. Not statistically significant. In other words, here, not no enough. There is no enough evidence to show the sodium level in beef hot dog is less than poultry hot dogs. Uh, we cannot say they are the same, but we have no evidence to reject it. It means no difference. You can say the same is okay, but actually there are no difference. Okay, and now how to run this? Yeah, for example, you can hear I misspell one. Okay, trust. Okay, then now you can check out how did I copy and paste the information. Basically. Is it? Oh, sorry. Yeah, you can type the information here. For example, select the string and take a screenshot of it. like this one. Like this one. For example, you can have your own notes like this one. First one. Second one. Then copy and paste. Then copy and paste. And then here. For example, okay, like this one. Okay, after finish this, okay, finish it. Then see, just you need to spend the time to take notes like this one. Then next you will, if you forget how to run the test, you can, okay, step 1, step 2, step 3, step 4, 5, then you will be done. You will be done. So how about the answer? This one. Okay, and let me show it again. Copy, paste, and copy, and paste, and calculate, and got the answer. And copy, and get it. And sure, to tell the p-value is this one, and it's a little bit different from our textbook, sure, because it's one tail, and we can highlight this. Okay, all done, all done. Okay, how about 5 minutes? We can run this. Let me show you here. Okay, please do this assignment. I know because the chapter 9.3 two sample test is a little bit hard and important for everyone, including the field in biology and the field of statistics and economics. Okay, so please spend 5 minutes to calculate, to run this, to write the notes. 5 minutes. Any question? We are close to the end of the class. Any question, please let me know. So, okay, we are done. See you next week. Okay, students related to the classroom, please let me know. I'm going to check attendance for you again. Okay, see you next week, everybody.